Well, let's look at quiz 4. Use the rational zero theorem to list all possible rational zeros for the given function. So that rational zero theorem or test tells us that the possible zeros are equal to the factors of a sub naught divided by a sub n. So here for this problem, a sub naught is that 8, and then a sub n is the leading coefficient, which is just 1 times x, right? So what we have in terms of the possibilities, and here stress all, so that would include plus or minus. So we have plus or minus. Here are the factors of 8, all over plus or minus the factors of 1. So what that gives us is plus or minus 1, plus or minus, it's just the factors of 8 divided by 1, which just becomes just the factors of 8, plus or minus 2, plus or minus 4, and then plus or minus 8. So it'll be that one. Next, here, find all the zeros of the polynomial function. Use the rational zero theorem, Descartes' rule of signs, and all of that. You don't need that. We're going to just use the use synthetic division. List the coefficients of the polynomial: 1, -3, -6, and 8. Always start with the smallest possible factor, so I start with 1. Remember, you bring down this 1, multiply 1 times 1, we get 1. That's -2. 1 times -2 is -2. We add, we get -8. 1 times -8 is -8. Remainder 0. But that's what you want. We can keep on using synthetic division, but let's just see what we have so far. We have now this x equal to 1 here. That's what that means. Implies that the factor is x minus 1. Okay? So let's list what we have. X minus 1 times, now I'm going to look at, these are all coefficients. It's not supposed to happen. We list those coefficients with the polynomials. That becomes 1 times x squared minus 2x minus 8. Remember, this term here is always 1 degree less than where we started because we did a factor. So you took out a factor, that is, you divide it by a linear term. Excuse me. Now, we can factor this trinomial. This is x minus 4 times x minus 2. And that's not right. That'll be a plus. So we get minus 4 plus 2. We get that -2. That's here. And then -4 times +2 is -8. So we're good. So if this be the case, we set this equal to 0 to find the zeros, that is the x values that make the polynomial equal to 0. And so that implies that x is equal to 1, x is equal to 4, x is equal to -2. So you're going to put these values separated by a comma in here. So you just list 1, comma 4, comma -2. What's the domain? You know, what's critical here are the values of x when the denominator is equal to 0, or the values of x that make the denominator equal to 0. Well, that would be x equal to 6 and x equal to -9. So we exclude those values and we get the domain. So that will go from -infinity to 6, parentheses, we do not want to include 6, union, excuse me, I made the mistake. We go from least to greatest. You've seen me in class do this, draw that number line. I'm doing that for you, but also for me. Start from the least to the greatest. Boy, if I could see and count, man, we'd be able to do something. So we go in that order, from -9 to 6, excuse me, union from 6 to +infinity. Another one for the domain. Here, notice that x cannot equal to plus or minus the square root of 121. Here we get plus or minus 11. Right? That or those numbers would make our denominator 0. So again, on the number line, so our domain would be from -infinity to -11, union with -11 to 11. Close that up. That's union from 11 to +infinity. Okay. Find the vertical asymptotes, if any, and the values of x corresponding to holes, if any, of the graph of the rational function. The vertical asymptote is simply those x values that would make the denominator 0. So the numbers that you excluded from your domain for a rational function. So notice here that x cannot equal to 0, x cannot equal to -6. We can't factor, that is, we can't cancel nothing out from the top to the bottom. And so we have two values here. Remember we call these the vertical asymptotes. So we have vertical asymptotes, x equals 0 and also x equal to -6. So you're going to put that in there, you're going to type that x equal to 0 and then x equal to -6. Find the horizontal asymptote. Remember we said we look at the degree of the numerator and the degree of the denominator. So my degree of the numerator is called that n, that's 1. And then my degree of the denominator, we call that m, that's 2. And so we said that if n is less than m, this implies that the horizontal asymptote is automatically the line y equal to 0. Well, that's what we have. We have 1 is less than 2. Now, here you have to put in there y equal to 0. Here for the horizontal asymptote, n is equal to 2 and m is equal to 2. If the degree of the numerator is the same as our degree of the denominator, this implies that the horizontal asymptote is the line which becomes the ratio of the leading coefficients. That's 21 divided by 7. So here we get y equal to 3. So you need to put in there y equal to 3. Okay. So 21 is the leading coefficient that we'll call a sub n there, and then 7 is the leading coefficient downstairs, which we call b sub m. Here, find the horizontal asymptote if any of the graph of the rational function. Well, the third possibility, notice that n is 3 and m is 2. So the third possibility, if n is greater than m, then no horizontal isotope. Well, we have that, right? We have 3 is bigger than 2. Use transformations to graph g of x. So for this graph for f, which is 1 over x squared, that this guy here has vertical asymptote x equal to 0 and horizontal asymptote y equal to 0. It's always positive because 1 is positive and x to be squared is always positive. So its graph, remember the horizontal, the vertical asymptote is x equals 0. Well, that's this line here. And then the horizontal isotope is y equals 0. That's the x-axis. That's that line there. And since the graph always wants to ride along with the isotopes, and since it's always positive, so that means that this graph exists here, and it does that. Now, this is for the function f of x. So we're going to do some shifting. Now, this -2 represents the horizontal isotope. So we have a horizontal isotope of y equal to -2. It's going to take the same graph of f, it's going to shift it down 2. Now, right here we have a vertical transformation or a vertical shift. Well, you remember you just called that the vertical isotope. So here, that's x equal to 3. So this guy shifts over to the right 3. So it shifts down, it takes this graph and it shifts it down 2, and then it shifts it over to the right 3. So we go down 2 from the axis, that's where the original isotope was. And then here, it moves over to the right 3. And I've already marked the correct graph there. And the challenge is looking at A and C, so you have to really look to see how they're shifting, right, to make sure that we get the count right. And so you look at that, and my screen may be a little bit small, and I can't hardly see it, but I had it earlier blown up on the other screen there in my math lab, and I could actually count to make sure that, okay, I go over here, 1, 2, 3, and then I'm going down 1, 2. Solve the polynomial inequality and graph the solution set on a real number line. Express the solution set in interval notation. So you remember what we said here is first factor if you can. So we have x plus 6 times x plus 2 that's greater than 0. Check that and make sure 6 times 2 is 12, and then 6 plus 2 is 8. So we look at these critical numbers, call them boundaries. We get x equal to -6 and x equal to -2. So we take the number line and we partition the number line based on those values. Now we're going to determine the sign of each interval by taking a test number. We're going to take that test number, plug it back in for x in this inequality here. So let's just say we test -7 there, -3, and then we'll test the 0 over there. So if you test that -7, I have -7 plus 6 times -7 plus 2. That gives me negative and negative, so it gives me a positive. Right? I'm going to say plus sign over here. Let's test the -3 plus 6, -3 plus 2. I get positive and negative. That gives me negative. Put the negative there. Now the 0. We get positive. Well, this guy said that you wanted the intervals or all the numbers of x that would make the inequality greater than 0. That means positive, right? Greater than 0. So it's going to be on the interval from -infinity to -6, and then from -2 to positive infinity. And that doesn't include the endpoints. So we want -infinity to -6. That's one interval that's positive, union with -2 to positive infinity. So you'll plug that in for A. And then let's see if we can pick out. So we know that since we have parentheses, that means it does not include, because it didn't have greater than or equal to. If it had greater than or equal to, then we'll pick the ones with, with the bracket. But here we're looking for the parentheses. So since we're looking for parentheses, we can exclude this one and exclude that one, exclude that one. So now we're going from -infinity to -6, and then from -2 to positive infinity. That's it right there. Right. It's not the interval between -6 and -2, because remember, that was negative. Right? That was negative. Here they asked for greater than. Greater than 0 means positive. So what are the intervals where we get positive value for the inequality? Let's do another one here. Very similar setup. So the critical values here would be x plus 6 equal to 0. So that implies that we get x equal to -6. And then here, x equal to 2. So we're going to partition the number line based on -6 and 2. Again, we'll test some points. So -7 over there. 0 is in between there, and then I'll test a 3 over here. So we're going to plug in, we have x, we're going to plug in here first the -7. So I have -7 plus 6 divided by -7 minus 2. The top is negative, the bottom is negative, so this is positive. So I'm just concerned about the sign. Next, we plug in 0, so we get 0 plus 6 all over 0 minus 2. We get negative. And then we plug in the 3. 3 plus 6 over 3 minus 2. We get positive. and you want it positive. Is it greater than 0? Right? So that's the interval from negative infinity to negative 6, and then from 2 to positive infinity. So we go from negative infinity to negative 6. And everything is parentheses because this is just greater than, didn't say greater than or equal to. We know that 2 is not included because 2 is down in the denominator, so we cannot divide by a 2. So this is union with here 2 to positive infinity. Let's see if we can find that. So here, there's no brackets, so we know we kick that out. We kick that out. We know it's not everything. So we're looking at from negative infinity to negative 6. That looks like it there. And then from 2 to positive infinity. That's good. There's nothing on that one. I don't understand that. And then we know it's not that one that's inclusive on the inside. So it's this guy here. Y varies directly as x. So that means that y is equal to some constant times x. And then it says when y is 96 and x is equal to 8 times the k. So we work that out, and that gives us 96 over 8 is equal to k, and I believe that's 12. So that was the first step. Second step, we find k. And then the third step, write the equation with the new value for k. Then the fourth step, find y when x is equal to 18. And we multiply that on our calculator. And that gives us is at 216. Y varies inversely. So step 1, we write this equation, y varies inversely as x. Remember, that's the fraction. Step number 2, they give us more information. That means they want to help us solve for k. Isn't that nice? We have y is 27 is equal to k over when y is 27, x is equal to 7. So we get 27 times 7 is equal to k. So that gives us, on your calculator, k is equal to 189. So step 3, we write the model, that is the equation, with the value for k, which is 189, and that's all over x. Now, step 4, find y when x is equal to 9. So we have 189 divided by 9. And so on our calculator, we get 21. Here y varies directly as x, that's k times x, and inversely divided by the square of z. Step number 2, they tell us that y is equal to 10, x is equal to 9 times k all over z is equal to 3, and that's to be squared. So that gives us 9 divided by 9, so we just have k is equal to 10. So step 3, let's rewrite the equation with the numeric value for k. 10 times x all over z squared. Step 4, find y when x is equal to 3 and z is equal to 12. That's to be squared. So that gives us 3 times factors of the 10 is 2 times 5 all over, that's 12 times 12. Say 6 times 2. That cancels. So we have y is equal to 5 over 24. Then the last one, the water temperature of the ocean varies inversely as the water's depth. So we'll use capital T for temperature, and let's just use little d for the depth. So I have T is equal to, it says inversely. So that's indirect, so that's K all over little d. All right? So that's step number 1. So step number 2, it says at a depth of 1,000 meters, the water temperature is 4.7 degrees Celsius. So we have 4.7 degrees Celsius is equal to this constant all over 1,000 meters. And it's pretty cool because you can tell that the constant is going to be in terms of Celsius meters, right? So here we solve for K. K is equal to, multiply that 4.7 times 1,000, and that gives us 4,700. That'll be 4,700 Celsius meters. But they're not particular here with the units, and that's fine. I just want to show you what's happening. So step number 3, so we have the temperature is equal to 4,700 all over the depth. Step 4, it says what is the water temperature, what is T, when the depth is 2,500 meters. So we have 47 all over 2,500. And so we get T is equal to, on our calculator, and it's pretty cool because you think about it, that constant and what we have up there, that constant was with respect to the Celsius meters, and this was in meters, and so our temperature comes out in terms of the actual temperature. You get 1.88 degrees Celsius on your calculator. The units of meters would cancel out. Well, that's that, and I wish you all good success. Thank you.